This week we're going to bring the frame home from the fabricator, and in order to do that we've got to have wheels under the frame to get it up onto the top of the car trailer and haul it out. So in order to do that, we went and bought we actually got donated from Carrera Marble a old Home Depot cart, and they were gracious enough to cut off the wheels. So we're disassembling the wheels, cutting off the tabs, and we're going to narrow it down so that the frame of the flight simulator will sit here, and it'll have sleeves that'll sit here and bolt up, and these will be able to be applied to the frame so it can go up on top of the car trailer to be hauled to the show, and then when we get to the show they'll be unbolted and taken off and the frame sits on the ground.
This is the original Lego model that was in the first video, and I've been modifying it so we can run our test programs on something other than the actual 1,000-pound armature beforehand, so that we don't start tearing up the garage, basically. Alright, so for each axis we have a motor and a shaft encoder so that we can spin that axis and at the same time know where it is. So that's fine for the pitch axis because we have access to the pitch axis from the ground. But for the roll axis, the motor and the shaft encoder are spinning around, so we need some type of slip ring contact to get signals into the rotating piece. And they don't make those for retail, so we had to make our own. So that's what these things are over here, and there's one over here also. Yeah, so that lets us get signal inside the rotating part, which you can see here. So that rotates, but then the outer armature also rotates. So yeah, that's why you need slip rings, because there's no way to get power into that middle piece easily anyway, when the outer piece is also moving.